Hi, I'm Curtis and welcome to my channel. This is the second video in my Nenina for Seestar series. In this video, I'm going to talk exclusively about the autofocus routine in Nenina. I'm going to show you how to set up the autofocus parameters, and I'm going to do some live demonstrations using Nenina to autofocus the Seestar. I'm also going to compare the focus point that is achieved when we use Nenina to focus the Seestar versus using the Seestar application to focus the Seestar itself. Now, if you're not familiar with how to connect your PC running Nenina or other software, you want to start with my first video, which is connecting the Seestar to a PC. I'll put a link to that video down below this. And if you missed the first video in this series, I talked about this profiles page. I also went through the camera, the filter wheel, the focuser, and the mount pages, showing you how once you connect to the Seestar transfers information to Nenina that you see here in these pages. So if you're unfamiliar with how to do that, you want to go back and watch that video first. I'll put a link to that also down below this video. But in this video, no pun intended, we're going to focus on the autofocus routine of Nenina. Before I get started, if you find the video useful, please like the video. Also, you may want to subscribe. And if you want to support my channel, I'll put links to my two favorite astronomy retailers as well as Amazon down below this video. You can support my channel at no extra cost to you by using those affiliate links for your purchases. And with the Amazon link, it doesn't have to be astronomy equipment. It can be anything that you normally buy on Amazon. If you use the affiliate link, I'll get a small commission for my channel, and I appreciate that. So tonight, let's talk about the autofocus routine in Nenina. All right, so let me start with the advantages of using Nenina to do autofocusing with your Seestar. We'll see those benefits a little more in detail once we get into the sequencer portion of Nenina. But as you know, with Seestar, we're very limited in our ability to refocus. The Seestar app will focus in the beginning of a session when it goes to the first object. We can force a refocus later if we're using something like the plan mode in Seestar to image a number of different objects over the night while we're not there. We don't have the ability to force it to refocus between objects, let alone at any time in the night that we want. Now, that's not the case with Nenina. With Nenina, we can set up a time interval, say 30 minutes or 1 hour, and have it refocus at that interval. We can actually set up to refocus before each new target. We can set up to refocus with a temperature change. And I believe, I haven't experimented yet, but since we have the camera's temperature from the Seestar recorded in Nenina, we might be able to use that to trigger a new focus every time the temperature changes by, say, 5 degrees C. Now, if it doesn't work with the camera temperature sensor, we can always add an external temperature sensor like many people do when they're doing astrophotography, and Nenina can work with that as well. And we can also force a refocus when the half-flux radius of the stars in our image increase by more than a certain amount. So there's a number of different triggers that we can use to refocus throughout the night based on time, temperature changes, target changes, or degradation in the size of the stars in our image, the half-flux radius. That gives us a lot more control than we have, obviously, with the Seestar. If we want to get the best possible images we can with the Seestar, we need to start with and maintain the best possible focus throughout the night. Now, the autofocus page is located under Options, so that brings up this column here, and then Autofocus, which is this page here. Now, I'm going to go over all of the parameters on this page, but before I do, I think it makes a little bit of sense to look at a actual focus curve that was generated by Nenina using my Seestar. So let's go there first. I'm going to go over here to the imaging page. We're not imaging anything right now. This is a log. So Nenina will keep a log of your most recent focuses. Here's a focus curve that Nenina generated for a focus routine that I did on the 4th of August. And this gives you some idea of what Nenina is doing. So when you do a focus, autofocus in Nenina, it will map out a curve like this. What it will do is it'll shift to one end or the other. You have a choice. You can go to the left side or you can go to the right side. In other words, you can go lower in focus number from where you currently are on the focuser, or you can go higher in focus number from where you are on the focuser. So the focuser was at some point here and it went down to a focuser setting down here below 1550. And then it worked its way slowly up step by step. And what it's doing is measuring on this axis is the half flux radius. If you don't know what the half flux radius is, you don't actually need to know. But the half flux radius is a measure of how big the star appears to be in terms of pixel size. So we want the sharpest, most pinpoint images possible, which means the stars also will be sharp and pinpoint. So it'll be the smallest half flux radius that we can get. So we want to get a minimum in this curve, but we also have to, in order to establish the curve, we have to go into focus and then out of focus on the other side. Now you can actually do the focus routine going from left to right or right to left, just depends on how you set it up in that focus autofocus page. And then Nenina will do a curve fit, and these red error bars are part of the fit. And the idea is to get a good curve and find the local minimum. So in this case, it found the minimum to be at 1584 setting on the Seestar. The half flux radius 1.34 at that point. It even records the temperature. This is the temperature of the camera. It records what filter is in there. And this is a goodness of fit called the R squared. A perfect fit would be 1.00. You're not going to get that, but you could get 0.99. And then this is how long it took to do the focus, 1 minute 52.19 seconds. So this is a nice focus curve. I believe I had the focus step set to 4. So what it wants to do is get at least 4 points on either side of the focus. And sometimes it'll give you more than that depending on where the focus point is relative to where you start. So let me give an example of that. I think this one here. So this had 1, 2, 3, 4, 5 points on this side, but it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on that side. And that's because the focus point was very much higher in count than where this thing started off. So it goes down a certain number of steps and then it keeps working its way back and it says, oh, I still haven't found the minimum. So it keeps adding points. Then it finds the minimum and it says, okay, I only need to take a few more to round out this curve. Had we started somewhere close to this final focus point, it only would have needed to go to here or here. It wouldn't have had to map those out. But in this case, the focuser must have been set somewhere down here, somewhere down around 1500 or so when it did this curve. And it said, oh, well, the focus point is way up here. Now, what's a bad focus curve look like? I had a bunch of those when I first started this out. There's a bad focus curve. And you can see it's all over the place because the settings just weren't right. And then slowly I worked my way up. Now this one got better, but it's not supposed to go backwards. All right, it looks good on one side, but not the other side. Getting better. And that's just basically as I was working out the focuser settings and finally started to get good focus. So that's what a focus curve looks like, a good focus curve. Again, it'll report the focus position, and you want to get a decent R squared. We'll talk about that here in a second. So now let's take a look at the autofocus setup page. So again, under options, autofocus. So this is the setup page. Now in the first video I produced Seestar PC control, I gave some starting points for the parameters on this autofocus page, and I don't think these have changed much from what I put in there the first time around. So let me go through each of these, explain what they are and why I have them set to where I have them. And also, you can just hover over each of these and you'll get an explanation of each of these. If you're not happy with my explanation, you want a little bit more, you should cross-check what I say with this. Also, you can go down here to the book in the lower left-hand corner. I've showed this before under advanced topics. Then you can go to autofocus, and there's a lot of stuff in here on the autofocus routine and the setup. So you might want to look at those as you gain experience. So first is the use filter offsets. So we do have different filters here, right? The dark filter doesn't count because we're not focusing when we have no light coming in. That's not an issue at all. But we do have the UV-IR filter and what ZWO calls the light pollution filter, which is actually a dual narrowband filter. And if you were doing a typical astrophotography setup and you were working with a mono camera, you'd have a clear or luminance filter. You'd have a red, green, and blue filter. You may also have some narrowband filters in there as well. And you don't want to have to refocus for every filter. So you would say, let me just focus with the clear or luminance filter, or in our case, the UV-IR filter. And then let me use offsets between the focus point for that filter and the red, the green, the blue, the narrowband, and so forth. So you could do that, except I don't really trust these offsets that came in from the Seestar when I connected the autofocuser between Nenina and the Seestar. These were populated by Seestar, and it's telling these offsets here for focus position, and I don't think these numbers make sense to me. So it's something I have to look at more in the future. In our case, I think you can simply operate with this turned not on, but off. If you were to turn it on, then you'd have to set one of these, such as the IR, as a focus filter. And the advantage of using that, especially if you have lots of filters, which we don't, we only have 2 here, is that if you're trying to focus with something like a narrowband filter, you have to do a longer exposure. And if you're going to focus throughout the night, maybe every hour, maybe every time the half flux radius changes or the temperature changes by a certain amount, you're going to have a lot of overhead where you're not imaging, but you're doing things other than imaging to improve the quality of your images. You want to keep that as short as possible. So that's a good reason to use the filter offsets. But until I understand, these numbers seem way too big of an offset number. So we're going to work with that off. Now, you have a choice how many steps you want to use. The more steps you use, the longer it takes to focus, the more overhead, the less imaging time. I would not use less than 3, and I probably wouldn't use more than 4 or 5. I use 5 when I'm using my Celestron C11 and Hyperstar. I might want to go rethink that and reduce that down to 4. I mean, after all, you're trying to fit a curve, so you need to have enough points to get an accurate fit of the curve. So I suggest 4, but no less than 3. Same thing as Nina says, no less than 3. Now, the focus method, this is using the half flux radius of all of the stars it can find in the field of view. And there's a contrast detection, but that is just like in Seestar, it's for things like the sun, the moon, stuff like that. So since we're focusing on stars in the background of the image, we want to use the half flux radius. There are several different types of curve fits, but the most common is the hyperbolic, and we'll stick with that. Next is the number of attempts at fitting the curve. So we have it set for 1, which means you go through, you map out all those points, and if you don't get a good fit, do you try it again? And we'll see in real time how long it takes to do that. I don't think you want to attempt more than 1, but that's up to you. Now, what happens if it fails to get a good focus fit? It simply stays at the focus setting that it started with when you attempted to refocus it. So you don't lose anything, you just stay where you were. Next is use the brightest end star. So we could put a number in here, like the brightest 5, the brightest 10, the brightest 15 stars. 0 was counterintuitive. It means use all the stars that Nina can identify. And that's typically what people use. That's what I use, and that seems to work. Next is this outer crop ratio. And what goes with that on the other side over here is the inner crop ratio. So we have the option of just looking at the field of view, a portion of the field of view. For instance, we could exclude the outer 10% of the field of view. And why would we do that? Well, maybe we are concerned that the stars tend to be a little more distorted and the optics is not as great towards the outer edge of the image, and you don't want that to affect your focus point. So you would crop that out. And I normally do that on my C11. I have a setting of 1 here and a setting of 0.9 here. I spent more than an hour trying to understand why I was getting a flat focus curve when I set this to 0.9. I still don't understand why it didn't work with the Seestar, because it works fine with my Celestron C11 with Hyperstar. So I just set these both back to 1. What a 0.9 here would mean is that the inner crop ratio is 90% from the center to the edge of field of view, and the outer crop ratio is at 100%. So we would be excluding the outer 10% of the field of view. If you put 0.8 in here, you would be excluding the outer 20% of the field of view. And I haven't played around with that since I tried 0.9 and 1, 0.9 for the inner and 1 for the outer. And as I said, I wasn't getting any focus at all. And I don't know why, but if you try it and you run into trouble, you'll know you're forewarned. Binning, we're not going to bin. We're going to stay 1 by 1. You could, I'm not so sure we can bin this camera, but there's no reason, in my opinion, to do binning here. Now, the threshold setting is, at what point do we say the curve fit is good enough? Do you set it to 0.95? Do you set it to 0.9, 0.75, 0.8, 0.85? You can play with this threshold, see what works for you. The tighter you make it, the better the fit has to be. That doesn't mean you're going to get a better focus. It just means the fit is better, which should imply a better focus, but it doesn't guarantee that. I think 0.85 is good enough for me. You can play with that parameter. Now, one of the 2 items that's very different from focuser to focuser is going to be the autofocus step size. And this took a little bit of doing. My Celestron motorized focuser, for example, uses a step size of 50. And it took me a while to eventually dial in the number 15 for the Seestar, but that seems to work quite well. This is something you can play with. When you look at the autofocus steps 4 and 15 for a step size, that means that you're going to do 4 times 15 and adjust the focuser down 60 focuser steps or up 60 focuser steps from where it is as your starting point in the focus routine. So if you're going on the downside and you're set at 1600, it would set the focuser starting at 1600 minus 4 times 15, which is 60. So that would be 1540. So it would go 1540, 1555, 1570, 1585, 1500. And then it would work its way up 1515, 1530, and so forth. And if it needed to do more points because it hadn't found the bottom and it doesn't have 4 points on the right-hand side, then it'll take a few more points as well. Same at the low end. If it didn't find the bottom after 4 points, it would keep taking points until it found the bottom, as I showed you in those curves before. Autofocus exposure time, try 1 second. Use the least you can get away with. Again, this is going to be overhead. We're not imaging while we're doing focusing. We're not auto-guiding with the Seestar. There is no way to auto-guide with the Seestar, so this needs to be off. And the focuser settle time is just in case you have some kind of focuser that has a little bit of jitter with it and some latent vibration. But I think the 0 setting works for most focusers, and it seems to work okay with the Seestar. Next is the number of exposures per point. Now, its default is 1. I suggest you use 1. Just like the number of attempts, I suggest you use 1. If you put this at 2, it's going to take 2 measurements at each focus step. And so it's going to take much, much longer, again, overhead when you're not imaging. You will have a better certainty in the curve fit, but I think 1 works quite well. If it doesn't work for you, you can try putting it at 2, but I'd be surprised. As I said, I'm keeping the intercrop ratio at 1 until I understand why 0.9 didn't work the way I expected it to. Next is the backlash compensation method. So what we need to do is we need to account for the fact that the gears don't mesh perfectly. And it's not just because it's a Seestar, it's any telescope mount gears won't fit perfectly. There is going to be some backlash. Otherwise, the gears would lock up and they wouldn't be able to move. So the question is, how do we compensate for the backlash? There are 2 ways to do that. And if you look here, one is called absolute and one is called overshoot. For the type of focuser we have, overshoot is probably the best method. What we're going to do is we're going to go in either the in or out direction and overshoot in that direction and then come back. So I have it set for backlash in. So that's the 6 here. You only want a number other than 0, either in the in or the out. You can do it either way. What this means is as we're coming in to a smaller setting on the focuser, we're going to overshoot in that direction and then come back a certain number of steps every time we go to the left or to a lower number on the focuser setting. And so this is another parameter it takes a while to dial in. And I have a number 10 that I use on the Celestron motorized focuser. So 50 and 10, and it took me a while to get this down to 15 and 6. I'm not saying they're the absolute optimum, but they seem to work reasonably well. You could have made this 0 and this 6, in which case when it goes to the right or to a higher focuser setting number, it'll go further out and then it'll come back 6 settings or whatever you put in there. So that's the autofocus settings page. These are the numbers that I work with that seem to work well. Try those. You can play around with those and see what works best for you. All right, so let's do a focus run. We have to go over here to the imaging page. And your setup of this page may end up being very different than mine. We'll get to this in, I think, the next tutorial. But for the moment, over here in this upper left-hand corner, I have the focuser. You see the focuser is selected. I could switch this to camera. It's telling me what the camera gain is, the temperature of the camera. Or click here is the focuser. And I can actually move the focuser here in and out. It tells me its current position here, 1606. Is it moving? Is it settling? It's not doing any of those. And I could target position. I could tell it to go to 1610 or 1580 and then say move, and it would go there. And 1606 was what I left the Seestar at about an hour and a half ago when I set it up, did the polar alignment using the Seestar app, and then I ran it through the focus routine a couple of times to see where the Seestar wanted to focus it. And as you see here, it ended at 1606. Okay, so now let's take a look with Nenina. And let's take a look on the right-hand side. If this wasn't here, you could just pull it up from this button here, Autofocus. That brings this up wherever you have it set up on your page. I have it set up on the right-hand side of my screen. You see, it could also be things like plate solving, or I could do manual focusing of targets, but we'll get into that stuff later. So for right now, we want to do a focus. Remember, we're at a setting right now of 1606 over here on the left-hand side, 1606. So that's somewhere in here. This thing is going to move 4 times 15 steps or 60 steps down. So that's going to put us at, what, 1540? And it'll start at 1540, so somewhere down in here. It'll step forward to try and find the focus position. Since the focus position was 1606 an hour and a half ago and it's cooled down a bit, I expect the focus position to be below the 1606, somewhere like 1590 something. We'll see. So let's start the focuser. So if we go down here in the lower left-hand corner, we see what Nenina is reporting what's going on. So it did the 1-second exposure. It downloaded the image. You'll see the image here. It's moving the focuser to 1561. I'm not sure why it moved to 1561. Did I do my math wrong? And it's got the first point. Oh. Yeah, it went to 1545, then 1546. Like I said, 1561. It was one step ahead of me. There it goes, another point. So it started down here on the left because I have it on the in instead of on the out. If I set it on the out, it would go the other way. So there's 1, 2, 3, and you see it looks like the minimum is going to be here. So it didn't get 4 points on this side, so it's going to actually go back and take an additional point. So this is a good example to see how this thing works. So it went back and took another point down here. And now it has to go back up this way and finish. So it added additional points down here. There it goes. Once you get 4 points on this side, and that's enough. 1, 2, 3, 4. That doesn't count as on this side. That's at the focus point. So the focus point 1587, like I said, it's going to drop down, so it must have cooled more than I realized. I didn't check the temperature when I was out there an hour and a half ago with the Seestar. So it was just a guess around the 1590s, but it's actually more than that. So you see this R square fit 0.96. Took like 2.5 minutes. That's because it had to go back take more points over there. And that's all because we started at 1606. We were too far to the right of focus. And if we had started closer to the 1587, we wouldn't have had to take so many points. So we're now, if we look over, we're at 1587. You see it up here. It says we're at that position 1587. So now let's start the autofocus again. Now this time, we're close to the focus point. So 1587 minus 60, that would be 1527 for the first point. That's what this looks like. I'll skip through some of this to speed up. So we have 1, 2, 3, 4 points on this side. That worked out okay. So we don't have to go back and take any extra points on this side. I guess it considers these 2 points too close to the focus point to count. It wants 4 clear points away from, on the left side and on the right side, away from the focus. So it'll be interesting to see if it counts this one. All right, so it did count this one. I'm not sure why it didn't count this one, and it counted this one, but it did. 1, 2, 3, 4. 1, 2, 3, 4. So that one obviously doesn't count because it's close to the focus. This one doesn't count for whatever reason. So 1586, very close to where we were, 1587, and temperature is about the same. So when I look over here, I realize that I did all the focusing with the light pollution filter in place. And that's okay. I was going to do both with the UVIR and the light pollution filter. It's just I was going to do it with the UVIR first. I didn't notice that the filter had been set up to be the light pollution filter. If you go back to options, or excuse me, if you go back to the equipment page, under the filter wheel, you'll see the LP is highlighted, the light pollution filter, same as it is here. So all those focus runs we just showed you were with the light pollution filter. Let's change this to the UVIR filter, and then let's go back to the equipment page, focuser page, filter wheel page, and you see the IR is selected. So we definitely have the IR filter in there. So let's do the focus run again, and I'll shorten the clip, not make you watch all the focusing here, but it's going to do exactly the same thing as it did before, only this time it has a different filter in place. Okay, so focused at 1591 with the IR filter. Let's run that a second time. Okay, all right, you see 1591, you see 4 points on this side, 4 points on this side. And I forgot to mention the last thing it does after it takes this last point and it decides it has a good curve fit is it goes back to the best fit point, which is 1591, and it refocuses there. You see, you can take a look at this. We can zoom in on this. A little too far, a little pixelated there. Here, let's use this to zoom in. There we go. And you can see the stars look pretty sharp. And if we look back to the one before we just did before that, it'd be this one, also 1591. Let's go back to the light pollution filter. And let's check that focus position one more time. You see it's focused 1584. So you see there is a slight difference, a little more than I thought, between the light pollution filter and the UV-IR filter. But nonetheless, Nenina is able to focus in either case. So that's how the autofocuser works in Nenina. You're free to play with these parameters. You can use these as a good starting point I wouldn't increase the steps more than 4. As you see, it makes sure it has 4 points on either side. These don't count because I guess they're too close. So there's some sort of algorithm that decides if they're too close to the bottom of focus position, then it doesn't count them as on the other side, which makes sense. You want a lot of leverage here. These have a lot of leverage. This doesn't have much leverage, nor does this. So it has 4 on either side. So sometimes you'll get a lot more points on one side, depending if you're starting close to the actual focus position, or if you're starting a little too far below it or a little too far above it. So what we will see when we look at things like the advanced sequencer, and we go down here to the focuser, you see we have autofocus after N exposures, autofocus after a filter change, autofocus after the half flux radius increases, after temperature, after time. We have a lot more control on our focus when we're doing a sequence of images, or even if we're doing one image all night long, we can keep track and make sure the focus stays sharp throughout the night. So I hope you found this second video in my Nenina for Seestar tutorial series to be useful. Don't forget to like the video, don't forget to subscribe, and you have the option to support this channel by using the affiliate links down below. In the next episode, we'll go over the Sky Atlas, how to find and slew to objects, and we'll talk about the framing page as well, and we'll actually take some images and see how this imaging page works as well. So thank you for watching. Until next time, clear skies.